Fitting lines. In this video, you'll learn how to describe the rate of change in y-intercepts for a linear model that represents a situation. Let's start by looking at the line of best fit. Some data sets follow a linear trend while others do not. The line of best fit is the most accurate straight line model for the data. We analyze the slope and intercept to understand the relationship between the variables. Now let's look at correlations. A positive correlation shows the y values increasing as x values increase. A negative correlation shows the y values decreasing as the x values increase. No correlation shows data points scattered randomly with no pattern. So let's look at some scatter plots and decide what the correlations are. We'll identify the correlation of data for each scatter plot below. On our first example, all of the points are kind of scattered randomly. They don't really follow a pattern. So this shows no correlation. Now let's look at the next one. As our dot moves from left to right, our x's are increasing. But while our x's are increasing, our y values are decreasing. So this shows a negative correlation. Now let's look at the next one. As our x values increase, our y values are also going up, so these are also increasing. This tells us that it's a positive correlation. Now let's look at the last one. As our x values are going left to right and increasing, our y values are going down, so these are decreasing, which represents a negative correlation. Now let's identify the correlation of data for the following sets that aren't graphs. The number of hours a person has driven and the number of miles driven. So let's start by calling x the number of hours. This is our independent variable. And we'll call y the miles driven, since it's dependent on the number of hours we drive. So as our number of hours increase, that tells us that the miles that we're driving are also increasing. So this represents a positive correlation. Now we have the number of siblings a student has in their math grade. Let's call x the number of siblings, and y will be the math grade. Since the number of siblings a student has no effect on their math grade, this has no correlation. Now we have the age of a car and then the value of a car. So x represents the age of the car and y represents the value of a car. So as x increases and the age of our car grows, our value of the car is actually going to decrease. So this shows a negative correlation. We have one more, and this says the number of downloads on your computer and the amount of memory that you have left. So x will be the number of our downloads, and y will be the memory left that we have on the computer. So as x increases, as we download more and more files, our memory left is going to shrink. So this represents a negative correlation. Which scatter plot below is best fit by the linear model shown? So we want to know which blue line gets most of the dots on that line. We can see that the line on B almost has every dot on that line, so this one fits the linear model best. Here's one last example. Which linear model below would best fit the scatter plot? Here are the four options we have to choose from. Let's start by drawing a line that would connect most of our dots, so then we can compare our slope and y-intercept to the options. Let's start by looking at option A. This has a slope of -4. Since we know that our slope is positive and not negative, this can't be our answer. So we'll cross this out and look at option B. Option B has a slope of 2. So since it's positive, it could represent our slope, but let's look at the y-intercept just to make sure. The y-intercept is -4, but on our graph, we don't have any negatives on the y-axis, so this can't be our line either. Now let's look at option C. Our slope in this equation is +6. +6 could represent our slope of our line because it looks like it goes up 6 and over 1. And our y-intercept is +4, so this also matches our line. So C is the equation that would best fit our scatter plot. Let's recap what we've learned. Some data sets appear to have a linear relationship, so finding an equation that fits the data can help us understand that relationship. Other data may not be linear or form patterns at all. So a dataset can have a positive, negative, or no correlation.